everyone, today we are going to start the trigonometry unit by starting off by solving right triangles. Before we get started, I want you to put your geometry brains back on and I want you to use the Pythagorean theorem to find the missing lengths of the following two right triangles. When you come up with your answer, please do not leave it in decimal form. Instead, I want you to leave it in simplified radical form. So please pause the video, try each of these problems on your own, and when you have an answer, please restart the video and we will see how well you did. All right, let's go ahead and look at the very first one. So remember that the Pythagorean theorem is a squared plus b squared equals c squared, and a and b are your side lengths, the shorter side lengths, and c is your hypotenuse of the triangle. So in this problem, I know that I'm going to call a the number 4. So I'll have 4 squared, and I'll call b 5. So that's going to be 5 squared equals c squared. So 4 squared is 16, 5 squared is 25, and this is going to be equal to c squared. 16 plus 25, that is equal to 41. So 41 is equal to c squared. In order to get rid of a square, we take the square root of both sides, and our answer is simply the square root of 41 is equal to c. We would not use plus or minus because it does not make sense to have a negative length. So simply our answer is the square root of 41. Let's go ahead and look at example number 2. For example number 2, we have a squared plus our b squared is going to be 9, so I'll call that 9 squared, is equal to our hypotenuse squared, which is 12 squared. So I have a squared plus 81 is equal to 144. I'm going to subtract 81 on both sides, and I find that a squared is equal to 63. I'm going to take the square root of both sides, and when I do that, I now need to simplify the square root of 63 even further. I know that 9 is a perfect square number, and it is a factor of 63, so I can rewrite this as 9 times 7, and the square root of 9 is 3, so a is equal to 3 square roots of 7. So hopefully you did pretty well with this warm-up, and if this warm-up was really easy for you, you will really like this first lesson. So our learning targets for today is for you to be able to say, I can define trigonometric functions of an acute angle of a right triangle and use them to solve right triangles. So we're going to be solving right triangles. And the first half of the trigonometry unit is going to be solving triangles in general. That means that we're going to be identifying all of the missing side lengths and the missing angles of a triangle. The next I can statement is I can use the angle of elevation or the angle of depression to find the missing side length of a right triangle. So angle of elevation and angle of depression should be very familiar terms to you, especially with just coming out of geometry last year. So some vocabulary words that I need you guys to remember is that the ratios of a right triangle side lengths are used to define trigonometric functions. They are sine, cosine, and tangent to start. There does exist a total of 6 trigonometric ratios that we are going to learn in this unit, but we're just going to start with sine, cosine, and tangent. So what I want you to do for the first example is we're going to let theta be an acute angle of a right triangle. Instead of identifying the 6 trigonometric functions, we're not there yet to try to identify the 6 trigonometric functions of theta. Instead, we're just going to go with sine, cosine, and tangent. And so for these types of problems, I want you to remember SOHCAHTOA. And SOHCAHTOA means that the sine of an acute angle is equal to the opposite side length divided by the hypotenuse, the length of the hypotenuse. So theta is going to be located here. The opposite side is always the side that the angle does not touch. So this is considered your opposite side. The CAH means that the cosine of your angle is equal to the adjacent side, the length of the adjacent side divided by the hypotenuse. And remember that the adjacent side is always the side that touches the acute angle, but it's not the longest side. It's just another side of the triangle. And finally, we have TOA, T-O-A, and that is equivalent to the opposite side, the length of the opposite side, divided by the adjacent side. So we have SOHCAHTOA. This is something I want you to please make sure that you remember, you know, and you study, and it should be pretty familiar for you. So the first thing we want to do in example 1 is we want to evaluate the trigonometric functions of angle theta. I don't want to know what angle theta is. I just want to evaluate the trigonometric functions, which means that we're just going to identify the sine, cosine, and tangent of theta. We're just going to leave our answers as simplified fractions. So I have leave your answers as simplified fractions. And please note that when you do your homework, you might end up with roots in your bottom because you might end up with a side length that'll have a square root in it. Please make sure that you have no roots in your bottom for your final answer. Because if you do have a root in your bottom for your final answer, you'll have to rationalize the denominator. So we would rationalize the denominator if you end up with a root in your bottom. Now, before we find sine, cosine, and tangent, we need to know all of our side lengths. So the first thing I'm going to do is identify what the hypotenuse is using SOHCAHTOA. So I'm going to call the hypotenuse C. So I'm going to write 8 squared plus 15 squared is equal to C squared. 8 squared is 64, 15 squared is 225, and that's supposed to equal C squared. So 64 plus 225, that is equal to 289. So 289 is equal to C squared. I'm going to take the square root of both sides, and I find that 17 is equal to C. So the length of my hypotenuse is 17. You may still have your Pythagorean triples memorized, and if that's the case, 8, 15, 17 is one of those special Pythagorean triples. If you don't have those memorized, no big deal. So now what I want to do is I want to identify what is the sine of theta. So the sine of theta is equal to the opposite, which so happens to be 8, divided by the hypotenuse, which is 17. So I'm simply going to write that as 8 over 17, and that is it. Next, I'm going to identify the cosine of theta. The cosine of theta is equal to the adjacent, which the adjacent in this case is 15, because it's touching our actual angle. So it's going to be 15 divided by 17. And then the tangent of theta, that is equal to the opposite over the adjacent. So that's going to be 8 over 15. And that is it. That's simply writing down all of your fractions and evaluating your trigonometric functions for your angle. Just the trigonometric functions that we know. All right, let's go ahead and look at example number 2. Example number 2 says, if theta is an acute angle of a right triangle, and we know that the cosine of theta is 3/8. What's the value of the tangent of theta? So what I'm going to do is I'm going to draw a right triangle. And I'm going to call this angle right here theta. And if we know that the cosine of theta is equal to 3 over 8, we know that the adjacent has to be 3 and the hypotenuse has to be 8. So I'm going to put in my hypotenuse as 8 and my adjacent side is 3. And what I don't know is I don't know what my other side is. So before I identify tangent, I need to know the opposite over the adjacent. So that means I need to find what A is, and I'm going to use the Pythagorean theorem to do so. So I'm going to write A squared plus 3 squared is equal to 8 squared. So I have A squared plus 9 is equal to 64. I'm going to subtract 64 on both sides, and I end up with A squared is equal to 55. I'm going to take the square root of both sides, and I find that A is equal to the square root of 55. So now I'm going to identify the tangent of theta, and the tangent of theta is simply going to be the square root of 55, which is my opposite, divided by my adjacent, and that is 3. Since I do not have a root in my bottom, I'm simply going to leave my answer as the square root of 55 over 3. Let's go ahead and look at example number 3. In example number 3, we're told that theta is an acute angle of a right triangle, and once again, the cosine of theta is equal to 7/10. What is the sine of theta? So I'm going to draw my right triangle and theta, and I know that the cosine of theta is equal to 7/10, which means I know that the adjacent side and the hypotenuse. So here's my adjacent side is 7 and my hypotenuse is 10, and what I don't know is I don't know the other side. I don't know the opposite side, and I need to know the opposite side in order for me to find what the sine of theta is. So I'm going to once again use the Pythagorean theorem. A squared plus 7 squared is equal to 10 squared. So I have a squared plus 49 is equal to 100. I'm going to subtract 49 on both sides, and I find that a squared is equal to 51. I'm going to take the square root of both sides, and I find that a is equal to the square root of 51. And so therefore, now that I know what a is, I can now find the sine, which sine is equal to opposite over hypotenuse. So my opposite is the square root of 51. So I'm going to write the sine of theta is equal to the square root of 51 over 10. So some of you may have never seen this symbol theta before. Theta kind of looks like a cursive O, and this is what we use to define angles in trigonometry. So now you guys have reached a more formal level of geometry, and so you guys are going to see this symbol of theta. Like I said, it looks like a cursive O. We have like the little curve coming kind of off on the side, but that is considered theta. Another way that some kids draw the word theta is where they draw an O and then a line going straight through it. That also means represents the symbol theta. All right, so this first lesson, like I said, was all about how to solve right triangles, and that's exactly what we are going to do. So in order to solve right triangles, that means, so you're going to see that language, solving right triangles. It means that you're going to find all of your missing side lengths, and you might use trigonometric ratios. You could also use Pythagorean theorem as well, which we want to find all of our missing side lengths and our missing angles. So we're going to find all missing side lengths using trig ratios, or you can also use the Pythagorean theorem as well. It just depends on what information that you have. The second thing we want to do is we want to find all missing angles. So you might end up working with inverse trig ratios, or just remember the 180 rule that all of your angles of a triangle add up to 180. And so we'll talk about inverse trig ratios in the event that we end up getting a problem like that. And then finally, we're going to make sure that our calculator is in degree mode. So if you have a graphing calculator, which for these problems you will be allowed to use a graphing calculator or a scientific calculator depending on your test. But in order for you to change your mode, just in case you do not know, there exists this word called mode, the button mode, that is located next to second. So if you press that button, some of your calculators will be in radian mode, some of them will be in degree mode. We want this to be in degree mode since we're talking about the degrees of angles. So I'm going to press my down arrow and bring it all the way over to highlight degree, and then it's blinking, and all you have to do to make it not blink is to press enter. So now it's over the degree mode, and now my calculator is ready to be used. All right, so what I want to do in example 6 is I want to identify all unknown angles and sides, and I want to list all 6 pieces of information. We want to make sure that all angles are rounded to the nearest degree, so we want whole numbers, and we want our side lengths to be rounded to the nearest hundredth. So the first thing I'm going to do is I'm going to decide what what information I already have, and identify what information I still need to find. So I'm going to write the measure of angle A equals the measure of angle B equals, and the measure of angle C equals. I know that the angle B is equal to 56 degrees and angle C is equal to 90 degrees. So I can find the measure of angle A rather easily because I know that all of the angles of a triangle add up to 180. So I'm going to write the measure of angle A is equal to 180 minus 90 minus 56. In which you can use the 90-degree rule as well, saying that if you already have a right triangle, you can subtract your other angle from 90 degrees and you'll have your acute angle. So 180 minus 90 minus 56, that is equal to 34 degrees. So cool, I already know what the measure of angle A is. So now I'm going to identify what little a equals, which little a is 13. Little b I do not know, and little c I do not know. And since I do not know two of my sides, or at least one other side for me to use the Pythagorean theorem, I'm instead going to use SOHCAHTOA in order for me to identify these missing side lengths. So with respect to the given angle, which we always use given information, little a is the adjacent side, little b is the opposite side, and little c is the hypotenuse. And what I'm going to do is I'm going to identify what little b is using my adjacent. So I know the adjacent and I want to find the opposite. Adjacent and opposite means I'm going to use tangent. So I'm going to write the tangent of 56, that is equal to the opposite, which is b, divided by the adjacent, which is 13. This is simply a proportion, and I'm going to make the tangent of 56, which is just a number, make it over 1, and then I'm going to use cross product. So I'm going to write 13 times the tangent of 56, that is going to be equal to b. And when you put the tangent of 56 into your calculator and times it by 13, you end up with a 19.27 units. So I'm going to write 19.27 units. I'm going to put a little UN at the end because sometimes we'll have units and sometimes we won't, but we typically write down some sort of units in this class. So now that I know what my opposite is, I now need to find my hypotenuse. Once again, use given information. Do not use this 19.27. What if you made an error? Now the next number is going to be an error as well. So you always want to use given information. So I have my adjacent is 13 and I want to find the hypotenuse. Adjacent and hypotenuse means we're going to use cosine. So I'm going to write the cosine of 56. That's going to be equal to the adjacent, which is 13, divided by my hypotenuse, which is c. Using cross product again, I'm now going to write the c times the cosine of 56 is equal to 13. I'm going to divide both sides by the cosine of 56. And when I do that, I find that c is equal to 23.25 units. And that is a fully solved triangle. Please make sure that you show as much work as necessary to come up with the right answer. I should be able to see what your process is, and it should make sense. So let's go ahead and look at example letter B. For example letter B, I'm going to identify all of my information that I know and information I need to find. So the measure of angle A, I know that that is equal to 37. So I'm going to write that it's 37 degrees. The measure of angle B I do not know, and the measure of angle C is 90 degrees. So I can find the measure of angle B rather quickly because I know that all of the angles of a triangle add up to 180 degrees. So I'm going to write the measure of angle B, it's equal to 180 minus 90 minus 37. And when you go 180 minus 90 minus 37, you find that the measure of angle B is 53 degrees. So now that I know what the measure of angle B is, that's pretty good. I now need to figure out what A is, which I do not know. I need to find what B is, which I do not know. And I know that C, which I'm going to call it little c since it's right across from angle C, is 22. We'll call it 22 units. Now with respect to the angle that we know, which is 37 degrees, little a is the opposite and little b is the adjacent, and we know the hypotenuse. So the first thing I'm going to do is identify what little a is, and little a is just so happens to be the opposite, and I know my hypotenuse. So opposite and hypotenuse means that I'm going to work with the sign. So I'm going to write the sine of 37 is equal to my opposite, which is a, divided by the hypotenuse, which is 22. And I'm going to make this a proportion over 1 and use cross product. So I have 22 times the sine of 37 is equal to a. And I'm simply going to put that into my calculator exactly as I see it, and I end up with 13.24 units is equal to a. So now I'm going to find what B is. So B is the adjacent, and I'm always using given information, which my given information is my hypotenuse is 22. Adjacent and hypotenuse uses cosine. So I'm going to write the cosine of 37 is equal to the adjacent, which is B, divided by hypotenuse, which is 22. I'm going to set this up as a proportion, and I'm going to use cross product. So I'm going to write 22 times the cosine of 37 is equal to B. And I'm putting that into my calculator, and I find that little b is equal to 17.57 units. And that is it. We have officially solved our triangle and have identified all 6 pieces of information, all 3 angles and all 3 sides. Let's go ahead and look at example number 7. For example number 7, it says, while standing on the Yavapai Point near the Grand Canyon, you measure an angle of 90 degrees between Powell Point and Woodrose, where are we at? And Woodforce, so this is supposed to be Woodforce, so there's supposed to be an F right there. So Woodforce Point, as shown. So we have ourselves a right angle right here. You then walk to Powell Point and measure an angle of 76 degrees between Yavapai Point and Woodforce Point. So here's our angle of 76 degrees. The distance between Yavapai Point and Powell Point is about 2 miles. So that's what we have down here. It's about 2 miles in between Powell Point and Yavapai Point. We want to figure out how wide is the Grand Canyon between Yavapai Point and Woodforce Point. So we want to figure out this distance of x. So using our information that we know, 76 degrees is my focus angle, and 2 miles is the adjacent. It's right next door to it. Opposite of the right angle is the hypotenuse, and I am not interested in the hypotenuse. Instead, I am actually interested in the distance between Woodforce Point and Yavapai Point. So this is my opposite with respect to 76 degrees. And so what trigonometric ratio works with opposite and adjacent? Well, that's going to be tangent. So I'm going to write the tangent of 76, that is equal to the opposite, which is x, divided by the adjacent, which is 2. So now I'm going to make tangent of 76 be over 1, and I'm going to use cross product. So I have 2 times the tangent of 76 is equal to x, and I'm simply going to put that into my calculator. And when I do that, I want to round all of my answers or distances to the nearest hundredth, and that's going to be 8.02, and our units in this case is miles, and that is equal to x. So the distance between Yavapai Point and Woodforce Point is 8.02 miles. We have one more page and then we are finished with this lesson. So let's go ahead and flip the page. All right, so we have a couple more vocabulary words that are going to be recaps of what we've already learned before, and that is called the angle of depression and the angle of elevation. So if you look at a point that is above you, such as the top of a building, the angle that your line of sight makes with the parallel line to the ground is called the angle of elevation. So angle of elevation is the angle that you create when you are looking up. If you are on top of the building, at the angle between you and a line parallel to the ground, which is going to be an invisible parallel line to the ground, and your line of sight is called your angle of depression. Your angle of depression is your angle that you create whenever you look down. Now, if you guys remember your angles from geometry, these 2 angles are called alternate interior angles. They're alternate interior angles between 2 parallel lines. Therefore, they are congruent to each other. These 2 angles have the same measure to one another. Sometimes it makes sense to use the angle of depression. Sometimes it makes sense to use the angle of elevation. It just depends on the problem. But the thing that I want you guys to know is that the measure of the angle of elevation is equal to the measure of the angle of depression. So we have 2 more examples and then we are done. Let's go ahead and look at example number 8. It says, you are measuring the height of your school building. You stand 25 feet from the base of the school. The angle of elevation from a point on the ground to the top of the school is 62 degrees. Estimate the height of the school to the nearest foot. So I'm going to draw our school. And a point, you stand at 25 feet from the base of the school. So I'll call this distance right here 25 feet. And it says an angle of elevation from the point on the ground of where you're at to the top of the school, which a height is always indicates a 90-degree angle. That angle of elevation is 62 degrees. We want to figure out what is the height of the school, so we're going to call that x. Now, with respect to 62 degrees, 25 feet is the adjacent and x is the opposite. And the trig function that uses opposite and adjacent is tangent. So I'm going to write the tangent of 62 is equal to the opposite, which is x, divided by the adjacent, which is 25. I'm now going to make tangent of 62 over 1 and use cross product. So I have 25 times the tangent of 62 is equal to x. Putting that into my calculator and rounding to the nearest whole number, I end up with 47 feet is equal to x. So the school is 47 feet tall. Or about 47 feet tall. All right, next, last example. It says a kite makes an angle of 59 degrees with the ground. If the string of the kite is 40 feet, about how far above the ground is the kite itself? Round to the nearest foot. Okay, so the kite makes an angle of 59 degrees with the ground. So if we were to think about this, we have a kite and it's floating in the air and it has a string that's attached to it. This is the string. Here's my right angle. And the angle that it makes with the ground is 59 degrees. So we are told if the string of the kite is 40 feet, which this is the string of my kite, it's 40 feet, how high above the ground is the kite? So with respect to 59 degrees, x is the opposite side, and the 40 feet is the hypotenuse. And the trig function that uses opposite and hypotenuse is sine. So I'm going to write the sine of 59 degrees, that is equal to the opposite, which is x, divided by the hypotenuse, which is 40. I'm going to make the sine of 59 be over 1, use cross product, so I have 40 times the sine of 59, that is equal to x. And when I put this into my calculator, I end up with approximately 34 feet is equal to x. So that means the kite is 34 feet, or about 34 feet above the ground. And that is our answer. And the end of this lesson. So hopefully today's lesson was pretty easy for you. If not, please make sure that you have a conversation with me immediately. I hope you have a wonderful day, and I will talk to you next time.